right, guys, I just wanted to give you one more short little lecture here, and we're looking at the picture that I drew on the previous slide, so you can kind of see all of it here. And when we left off, we were talking about how endothelial cells essentially are capable of migrating and proliferating, and we kind of talked about that right here. Let me get a better marker because that one's pretty poor. We talked about that right here. We talked about VEGF signaling and how VEGF kind of mediates all this. So now I want to talk a little bit about inflammation and a little bit about these matrix metalloproteinases. And I'm going to kind of zoom out, and here is another section that I want to look at, and we're kind of zooming back in. And as you can see here, we have our endothelial cells, and we have our receptors, right? Here's the VEGF receptors. And holding these or stabilizing these cells side by side are these adhesion molecules, okay? So you can see here and here, right? If I put a circle around it, and here and here and here and here. And these are like anchors, all right? So these anchors are keeping these endothelial cells in place. So how do these endothelial cells migrate and move and proliferate when we have these anchors essentially keeping them in place? Well, one of the ways we get past this is through the use of inflammation. So we know that when we are exercising, and when we're exercising frequently, we upregulate inflammation, right? It's a part of the DOMS process, right? Delayed onset muscle soreness. So I'm just going to kind of draw these star-like pictures here to kind of represent inflammatory markers or inflammatory molecules. And these inflammatory markers, when they become present in the blood, they have the capability of kind of moving down into what we call the extracellular matrix, right? So if we look at endothelial cells, we know that they exist here. We know that beneath them, right here in this area, are smooth muscle cells, and I kind of noted that here with the type. And we know those smooth muscle cells are going to respond to what the endothelial cells tell them to do, or what the sympathetic nervous system tells them to do. Well, underneath that, when we're looking at vessels, we have this kind of patchwork of various fibrinogens down in here like this. And this is what we kind of call the extracellular matrix. And this is just kind of made up of kind of stiff tissue, right? It gives the vessels a little bit of rigidity, and it's just a little bit stiff. So in order for, let me kind of clean this up. Let me back up a little bit here. In order for these, let me get this here. Let's clean this up. In order for these endothelial cells to be mobile and to be able to move, inflammation has to recruit something called, and we'll do this, MMP. MMP. And that is matrix metalloproteinase. And these are, as I drew on my previous slide, these are molecules or proteins, we'll say proteins, that act like scissors. And these are really important for vascular remodeling. So where do these MMPs live? Well, they get recruited in the blood, and I'm going to draw this like Pac-Man. So certain cells will secrete MMPs. They get recruited. Here's some MMPs. Here's some MMPs, right? But they also exist on the membrane of endothelial cells. So we can have MMPs here. We can have MMPs here. We can have MMPs here and here. And when they get recruited along with inflammation, because we know inflammation is such an important process, right? Here's some inflammation, here's some inflammation, here's some inflammation. And I'm being very broad in general. We can say that these inflammatory proteins right here, we can say that these are monocytes. And that's C-Y-T-E-S, right? And a monocyte is, they're inflammatory markers such as IL-6. We've talked about IL-6 before, right? Interleukin-6, IL-22, right? Interleukin-22. We didn't really talk about that much, but we saw this one before, TNF-alpha. We saw that before. Let me make that F-alpha a bit more clear. And these inflammatory proteins, as well as MMPs, they will move into the extracellular matrix down here, and they will start chopping up that matrix to allow cellular migration of the endothelial cells. Now, the other thing they're going to do is they're going to chew up some of these adhesion molecules, right? So we can get MMP erasing that, MMP erasing that, erasing some of these anchors down here, erasing some of these anchors over here, erasing some of these anchors like this, right? And what begins to happen now is that these molecules, if inflammation and if MMPs kind of clear the way, this is essentially what they'll do. If this MMP comes down here, right? Oh my goodness, sorry about that. Comes down here and enters this area here, it can start kind of hacking up all of this material here, right? You see how it's kind of clearing a path? And it's clearing a path, and then it could get to the basement membrane right over here, and it can clear a path. Now, what does that do? Well, when we were talking about the migration before, that will allow this cell, this endothelial cell right here, to begin to migrate, right? And when it migrates, it moves. Right? And now a path has been cleared. And then let's say this cell migrates as well. And we could say that this is 1, and this is 2, and this is 1, and this is 2. Right? And then that can continue to happen. So we can get another cell migrating here, and another one here. And look at what happens now. We're getting sprouting. Right? So this existing vessel right here received information from VEGF, recruited inflammation, recruited MMPs, and inflammation and MMPs kind of cleared the path so that the cells could migrate. And then what begins to happen is, of course, once they migrate, they create these lumens, right? And what we see here is, if we zoom out, this vessel here can continue on. Let me switch it to the right. This vessel here can continue. Oh my goodness. This vessel can continue on this way, right? Here's the top of that vessel, right? We can have red blood cells floating through here. And now, because a new basement membrane has, or the basement membrane has kind of been chewed up right over here, right? This is the basement membrane for that vessel, right? Now, this sprouting will create a second vessel, right? And that second vessel can begin to branch. And we can have more blood. So now the red blood cells are capable of not only going this way, but also coming this way. And that is how the MMP and the inflammation assist with that entire process.